Hi guys, and welcome to this PCG tutorial. So today we will spawn some rocks and then spawn some grass around the rocks. I love the PCG in Unreal 5.2 so far, and I intend to use it for my whole game essentially. So like spawning NPCs and spawning all the foliage. I'm actually using the voxel plugin. I intend to kind of incorporate that as well, but we won't look at that today. So if I extend this PCG, as you can see here in the X direction, for example. So now we generated some more, and I can do the same in the Y direction. And this is just my computer being slow while recording and everything. It generates random rocks and then grass around each rock, and also offsets the points random and everything. And this is nanite meshes as well, both the foliage and the rocks. And this is just the same mesh over and over, but we can easily swap that. So let's get started. First of all, you need to go to plugins and enable both of these, I think. After you've done that, you just go into PCG and then PCG graph, and then it creates a graph and you get a new graph. But we will take a look at the one I've made here. All right, so let's start from the beginning here. So I start with a world ray hit. So let me just disable these guys. So as you can see on the left, everything disappears. So some easy, quick shortcuts. You got E for enable and D for debug. We'll be using D for debug a lot, and also the inspect. So if you're used to Houdini, this is basically Houdini inside Unreal. So it's really cool. All right, so the world ray hit is set to world dynamic. So if I press D here, nothing happens. And then we plug that into a surface sampler. So here we set it to 0.1 points per square meter. So if I press D here, we can see that we have points scattered on the whole surface. So if I now change this floor to static and force regen up here, you can see that all the points disappear. And that's because this world ray hit is set to world dynamic. So that needs to be movable. If you're using a landscape, it's much more efficient to use the landscape height and just plug that in. But I'm not doing that, so this is another way to spawn points. And if you have other meshes in your world, these rays will hit those as well if they are set to movable. So world dynamic. Okay, so we scatter some points in our box here. So I'll just go here. And then we change the bounce. So I set the bounce to be from 1 to 1.5. Then I prune stuff. If we increase this to like 10, you can see that points are disappearing. So here before we had 3 points, but now we only have 1. So basically you're extending the bounds, and those that are intersecting in this node are removed basically. So the points aren't being scaled, I don't think. If we press I, we can get the attributes and select it from here. So here you have all the attributes from this node. So if I select this and press I, we change information basically. So here, this is just as it is in Houdini basically. So you can create attributes and everything. So that's really powerful, and I've just gotten started. I'll probably do more tutorials or walkthroughs basically. Anyway, then we transform the points. So here you can see that if I disable this node, we change a lot of the scale and also the rotation of only the Z axis. So we don't touch the X or Y. And that's really powerful. And you can see on the nodes as well that they are now rotated. So from this is the debug flag to this. So we scale rotation from 0 to 360 and the scale min from 0.45 to 1. Let's move on. Then we transform the points, which just scales up some of this should be the other way around. Yeah, doesn't matter, I don't think. And this is for like the big rocks. So then we have a bounce modifier, and I'm just scaling up. Let's take this part soon. All right, so yeah, everything is then connected to like a static mesh spawner. So if I enable this and take off the debug flag, we can see that we got our rocks. The static mesh spawner spawns a mesh or multiple meshes on each point basically. But then I wanted all of the rocks to move up a bit. So I'm just offsetting them with bounce modifier, and then I take mass This is really powerful. You got all of your math functions here. So in the input here, I use $extents.z. So if we go to inspect this one, right click and inspect, or I, we can see here that extents dot, let's see. It's not showing up there. I pushed the plus sign here, and then we had the extents, and then to get a single value, you just write .z. So it's not a vector, it's now a float, I think. And then I got a static value here, which is the attribute create attribute. So this is how you create attributes, and that is basically how much I want to push them up. Because all the rocks needs to be pushed up a different amount regarding to the scale. So I multiply this by the extent and then multiply the box offset to the scale.z. So this outputs this as box offset. So if we press I here, we can see that the different ones have the same box offset, 2.85. And then if we go to this one, we multiply that with the scale of each point, basically. So now it's a different amount. And then we add that to the position.z, adding the box offset and outputting that to position.z. If we take a look at one of the rocks and we disable this node, this one is translated much more than this one, for example, because this is a smaller rock. Cool. So this is pretty easy to do. Just scatter some rocks, and you don't even need all of these nodes. Basically, you can basically take away all of these ones and you still get the rocks. So now it's just the self-pruning into the static mesh. So you just need points and then you can spawn meshes, basically. This out node doesn't need to be connected as well. This is spawning all the meshes with this node. So the out node is mainly used, as I understand it, for subgraphs, which I haven't been using because this is so new still. But then I wanted some grass around, or like particles around, or I wanted some moss, for example, to be on the rocks or around the rock. Or for example, if I spawn trees, I maybe want some moss only on the north side of those trees, like in nature. That's why I looked into how to do this, basically. So if we go into the grass here, let's see here. So I take the points, these points, and then I take a grid here. Let's see where the grid is here in the middle. So here we have a lot of points. So this is not connected yet to anything. So it just spawns in the middle of the world. It's like at 0, 0, which you can see here, the grid center position. We can skip this node for now. Then I copy to points. This node was really important to find for me, and I had to like play around for a long time, basically, to find this. But if we take a look at that, now it's loading as well. We copy all of those points to each rock. So now as you can see here, I got 15 FPS. So my performance isn't that great right now, but that's okay because I'm recording as well. I copied all the points, but it's hard to see right now. But basically, I'm now copying, I think we can do like this. Yeah, so if we inspect this node, you can see that the scale is inherited by this stream, and we can set that scale inheritance target. But I don't want like a really odd looking stone to spawn like a rectangular like this. I want all of them to have like the same area around them and then do some randomization. That's why I got this transform point where I set the scale min and max. So if I enable this and you have a look at the scale X on this copy points node, you can see that we set all the scale to 1. So now it's like uniform grids around each rock, no matter how big or small the rocks are. And that's just what I wanted for this example. So then I transform them. So it's like a random offset from -50 to 50. So now you can see that we scattered the points a bit. And then we got the same thing again, like a bounce modifier and then the self-pruning in order to remove points that are overlapping. So if I just enable these two and then put my flag on the self-pruning, you can see that we removed a lot of points. And that's one thing that I already recognized, that you don't want to be generating lots and lots of points and then just remove them because of performance, basically. Because this scene is pretty small still. So that's something that I'll have to look out for. Yeah. And then we get these points from up here, like the big rocks, and we put it into a difference node. And the difference node doesn't do anything by itself except for creating a new attribute. So let's see if we can see that. So you can see here the density values aren't 1 on all of them. And that's because they are overlapping with the rocks somehow. They're still there, they just create a new attribute. So then we can pipe that into a density filter, which actually removes them, as you can see here. And you can play around with the lower bound and upper bound and stuff like that. So around all the rocks and on the rocks, inside the rocks, there are no points. And then we spawn the grass. So that's the last part. Okay, so just to recap, we got a world ray hit, we sample points, then we remove points, we do some random points to it, and then we move them up, the rocks, and then we spawn the rocks. Then for the grass, we scale it to 1, and we copy a grid, copy to each rock, so each rock has a grid over it, and then we transform some random stuff, and then we remove a lot of points. Then we remove the points on the rocks with the difference and then the density filter. So we create the density filter attribute and then we actually remove the points and then we spawn the grass. Yeah. Feel free to copy this. I'll do a lot more like this for my game. So I'll probably do some more videos related to PCG and voxel and Houdini stuff. So if you're interested in that, don't forget to subscribe and like. If you wonder anything, if I didn't explain good enough, please let me know. And let me know what issues you have or what you're working on and everything. And I'll see you next time. Bye.